first panelist is Mr. Rainer Glatz. Welcome to the panel discussion. He holds a degree of computer science, and he's the director of the German Machine Building Association, the VDMA, for the division software and electrical automation. And he's also the leader of the industry platform Industry 4.0, which we are going to hear a few details about during the panel discussion. The next participant, which I would like to say hello to, is Mr. Otto Urbanek. He's the managing director and owner of Dr. Urbanek Management Technology, Ges.m.B.H, which is the same as limited in English. And he's an expert for energy efficiency for the plastics industry, and very well known because he was the former CTO of Engel Kunststoffmaschinen and the former COO of Mannesmann Plastics Machinery, and a former board member of MPM, the member of the executive committee of Krauss Maffei Corporation. A lot of things you've done throughout your life, and we want to really benefit from your experience in that discussion. I also would like to welcome a young gentleman, Mr. Karl Fischereder. Welcome to the panel. He's the owner of and managing director of Dorninger Hytronics, a small to medium-sized new company, innovative company, which deals with hydraulic solutions for the plastics industry. And he's one of the experts for solutions which involve servo, motors, control, and also hydraulics. And we are going to hear more within the panel discussion. And last but not least, a colleague of mine, Thomas Rienessl. Welcome to the panel. He's a B&R specialist in international sales manager within B&R, and he's the industry specialist for the plastics industry. If we see the ongoing changes in the consumer behavior of the end users and the consequences for future production and also for business processes, we are going to see that this will result in an individualization of the production. Everyone has different needs, so this means we need to plan for batch size 1, but in serial production. And therefore, we need resource and efficient, energy-efficient solutions in order to reduce the carbon footprint, and of course, also to reduce costs and to remain on the competitive edge. I would like to turn to Mr. Glatz, and the question I have to you is, you promote Industry 4.0, and currently in Germany, this is a big buzzword. Can you explain what Industry 4.0 means, and more importantly, how Industry 4.0 helps end users reshaping their production processes?
Okay, first of all, for me, Industry 4.0 is not a buzzword. It's made to a buzzword by vendors, but it's still a vision. It's a vision for the future. We think about 10, 15 years, and we see Industry 4.0 is the integration of the real world of the production with the virtual world of the IT. And that's the next decade, the next step, and we see a lot of integration between companies, between the suppliers, the producers, the integration, the vertical integration from the ERP, we call it, down to the sensor. And also during the whole process lifecycle management, the design of the products from the beginning to the end. And there we have to integrate all these technologies, and that's for us Industry 4.0.
When you talk about Industry 4.0, you also talk a lot about a smart factory. What are the characteristics of a smart factory, and what are the benefits for the producer of a smart factory, Mr. Glatz?
A smart factory, we call, is a factory using technology coming from Industry 4.0. And it means that we can better, we have the better processes in place, we have more flexible production, we have the client incorporated in the production, means everything is someone networked together. And we have a much more higher flexibility, and the ideal world would be that we have batch one production in a case, in a matter that it's as economic as mass production. And we will incorporate the client in our production process.
Now we talk about the production process. Let us turn to the machine builders. How will a machine going to look like according to Industry 4.0? What characteristics is it going to have to support a smart factory?
Maybe there's not in the physical way, it is not very different. Maybe the shape, design will be maybe changed. We maybe see iPads or tablets. We see a little bit on wireless communication, stuff like this. The physical machine could look a little bit like today, more modern, but still shapes we saw in the past. But the inside, the processes which are incorporated in the machine, that is changed. We speak about new ways of interaction, of new business models, of more engineering. And you also have the questions about efficiency. We think the whole questions about energy resource efficiency has to do a lot with intelligence. If you do not control these processes with intelligent technology, you will not have the benefits what you want to have in the area of efficiency. That's interesting also for me, what people in this area are saying.
And here you mentioned a keyword, and this is controls. Thomas, you're a specialist for controlling machinery. How can an automation provider like B&R support principles like Industry 4.0 and help implementing these principles?
Well, thank you, Markus. Industry 4.0 definitely will change the world and will also lead that IT integration will take place in the production process and also on the machinery level. And as an automation provider, we also have a very important role here because most of these things will be on the controller base and also in distribution of intelligence, components becoming more intelligent. So this will be key also for the automation provider. Such technologies need open technologies, and for example, we have already technologies available that will require what Industry 4.0 is demanding. For example, with Ethernet PowerLink and open safety, we have open protocols on the market that on one hand allow fast communication, but also give the bandwidth of an Industry 4.0 operation, because Industry 4.0 will require a lot of data communication through the production process. So that's for something what we can do as a technology provider to help that machines are Industry 4.0 ready. And the second level is on the engineering. Industry 4.0 will also require a lot of integration on the engineering side. So open engineering platform like integration of ECAD systems, modeling, simulation things are basic functionalities that will require Industry 4.0, and thus this is a very important key point here.
Mm-hmm. Thank you. I wanted to focus on one keyword Mr. Glatz has also mentioned, and this is energy efficiency. And here we've got a specialist, Dr. Urbanek, and the first question I have for you, how do you determine energy efficiency? And how do you know what is energy efficient and what is not energy efficient in the plastics industry?
This is really a very difficult area. Well, in the study we could make for Euromap, we found out that there's a huge gap between the energy consumption of a factory versus the energy consumption of a machine versus the heat input into the material, the enthalpy. We found out a relation, the 9-3-1 relation. 9 for the factory, 3 for the machines, 1 for the enthalpy. So everybody, I think, would have assumed that in plastics converting, the enthalpy would have a major part of the energy consumption. But in reality, it is not. It is not. If the enthalpy is 1, then the energy consumption of a factory typically is 9 times more.
So you're talking about an efficiency of about 10%.
Yeah, well, there are other productive processes in the production, but the energy efficiency of a whole production is in reality very doubtful. So I usually speak about a black hole because a lot of energy gets lost, and typically nobody really knows where it goes to. There are many things, many production factors involved in producing a product. But where the money really goes to, where the energy really goes to, nobody really knows precisely.
Let us shed some light into the black hole. And the question is, how are you able to improve energy efficiency at a producer side? Here you're the specialist. What are your suggestions?
Well, I always say, as long as you do not really focus on the production process, on the process to produce a certain product, you are not doing right. Therefore, you have to consider all energy consumers along the production chain. You have to collect data, yeah, from each production device. And based on all these data, on this databases with real numbers, then you can first think about, well, what kind of improvement can be done, what would be an optimization to the process. And as a result, you get out of this analysis better utilization of your production devices, better process parameters, and so if you think about investment, I would say you get the right equipment in place.
Mr. Urbanek, you mentioned that it's very important to measure the energy consumption at any single location. Thomas, how can B&R contribute to making sure that you're able to measure what energy is consumed at any single location? How do you do that?
Yeah, Markus, that's a good question. Well, again, it's technology that we need to provide here. And we, for example, in B&R, we are showing here on the K-Show the first time a system that is collecting data on a factory level. Because producers have many machines in their factory from different brands, even with different controllers. But we have now the technology in hand to collect this data. Not only collecting data from energy, also collecting data from machine utilization, also collecting data of the condition of the machine. All these parameters together, when you collect them and you analyze them, you have the capability nowadays to get real-time data on the production site, where you then can derive activities out of there. You can optimize your production, you can increase the utilization of the machine, and you can also identify by cost per product where is your energy used during the production process. That is key because this will allow you, first of all, to optimize your production on a cost point of view, but on the other hand, also give you the ability to derive this information, what you're going to do when you produce further products of same or similar kind. And we're showing that in our booth also. We've made a test installation in Austria. We figured out that for a medium-sized plastic producer, such an investment in a system would pay off in an average of 6 to 12 months. And this is really valuable for the producers for the future.
6 to 12 months for an investment, that sounds very much like a no-brainer. So it's very easy to convince people if you point out what type of cost and what amount of cost you're able to save with an investment. You simply need to measure it. And that's what you're able to help with. But let's turn to Mr. Fischereder. And the point here is, let's talk about technologies to conserve energy. and to make sure that the least amount of energy is used for production. And you have engineered quite a few systems which led to a dramatic energy savings. And you call these machines to be powered with hybrid hydraulics. The question I have is, what is hybrid hydraulics? And of course, how does the technology look like and how can it be employed?
First of all, the concept of the hybrid hydraulic technology should be defined precisely. A lot of names were created on the market for this new technology for energy efficient pump drives. They all mean essentially one drive system. The standard AC induction motor as a drive of a variable displacement pump is replaced through a synchron servo drive or frequency inverter drive, usually combined with a fixed displacement pump. In the plastic injection machinery, the servo motor combined with an internal gear pump became accepted. And with the dynamic capability of the servo drive, the accuracy and the repeatability of the machine was increased in addition to the energy savings and the reduced recycle time. Another very important point is the reduction of the sound of the machine, which is now possible because the servo drive is only audible when it's really doing work and it generates no noise in those times where the hydraulic is not needed.
So there's also things like a perfect combination. You conserve energy and on the same time you provide a machine which runs quieter and more precise. What I would be curious on is, can you give us some concrete numbers based on real-world examples?
Yes, one of our first applications where we installed this new technology was a rubber injection machine. After a detailed cycle analysis, we came to an estimation of about 70% energy savings with the new servo pump and some changes in the hydraulic circle. After installation, the end customer confirmed us 71% energy savings exactly for this cycle, which was a great result and led to a very short return of investment time.
This is a great savings, 70%, and this is in times where energy prices keep on rising. So the question from my side is, how were you able to realize these savings? What technologies did you employ and how were you able to run the system with such a great efficiency?
This is very easy to explain. We installed the start-stop technology, like already common in cars, when you drive in a traffic jam and the motor is started and stopped automatically. With one difference. In a hydraulic machine, we all the time have a traffic jam. That means, for example, in a plastic injection machine, the hydraulic drive is used around 70%. The rest, the 30%, is idle time. Let me bring an example. A 75 kilowatt standard induction motor with a standard pressure regulated piston pump needs around 9 kilowatt standby power only for the motor and for the pump to hold standby pressure of 250 bar. This means in a 3-shift production you can save up to 2,700 euro a year energy costs only when you switch off the machine in this 30% idle time. And this is now possible with the new servo drive. You can stop the machine down to 20 milliseconds short breaks. The second point is due to the dynamic and accuracy of the servo drive, we are able to replace hydraulic servo valves and proportional valves. This means, for example, for a closed loop position control or pressure control, we do it directly with the servo pump and we substitute a resistance-based valve control through a volumetric-based pump control. This saves another double-digit percentage of energy, and at the end you can dramatically reduce the cooling circle of the hydraulic. In the plastic injection mold machines, we are close to 50% market penetration. We see a lot of potential in the future. This is our humble contribution for a resource-saving future.
Okay, this sounds like a very good possibility. You invest into servo technology, but save on other locations, on the pump side, on the cooling side, and thus winning energy efficiency. A question I have to you, Thomas. What kind of B&R technology was part of that system which conserves up to 70% of energy?
Well, Markus, the technology is based on B&R service technology, so servo drives and servo motors. Obviously, the products that we have cover the dynamics that is required for such a technology. But let me bring also the software point here. What we are following here is an easy-to-use software concept. That means these precise controllers that are required for such kind of control system are encapsulated in a technology library. For the user of such a technology, it's really a seamlessly integration. This means that this technology becomes just part of a simple application inside of a plastic machinery. This is the way we approach them.
So let me summarize. First, we see that there's a change in the consumer behavior, and that change in consumer behavior will drive change throughout the machinery and the production process at the producer sites. And here Mr. Glatz commented and pointed out solutions in terms of merging the real world and the virtual world with Industry 4.0, which is a concrete thought on how the production in the future is going to take place. And his clear statement is the ones who are going to be first are going to be the most successful people, the most successful companies. Mr. Urbanek pointed out the importance of energy efficiency, that the production process nowadays works more like a black hole, that we need to bring in some light into to improve energy efficiency. And we all heard from Mr. Fischereder about technology possibilities to reduce the energy consumption by more than 70%, let the machines run quietly, more precisely, and saving money by improving the hydraulic installation. And Thomas explained how B&R is able to contribute technology first to measure energy, to bring IT and the real world together inside a B&R controller, and how B&R is able to provide technology for energy-saving drives, hydraulic drives, hybrid drives, but also full electric drives. And therefore, we are able, as Mr. Fischereder said, to provide a machinery altogether with ideas from 4.0, energy-saving technologies with hybrid hydraulics, with energy measuring possibilities to determine what energy goes through the black hole and what energy is going to conserve, with technologies which Thomas pointed out from B&R, like the hydraulic drives, hybrid drives, and also energy measuring possibilities with B&R. And with that, we've got a very round possibility for you, for the plastics industry, to conserve energy and at the same time save money and build a system which is future ready with Industry 4.0. Thank you very much for your participation on the panel, and I would like to thank you for all your contributions.